Hey guys, how's it going? I'm Chio. So today, I want to talk about something you probably touch, use, or sit inside of every single day, and yet almost nobody actually knows where it comes from. I'm talking about oil, petroleum. The stuff that gets pumped into your car, turned into your phone case, your clothes, your medicine, basically half the objects around you right now. You've probably heard the classic answer since you were a little kid: dinosaurs. Oil is just squished up dinosaurs from millions of years ago, right? It's honestly one of the most widely believed facts in the entire world. Kids draw pictures of it in school. Cartoons joke about it. Even some gas station commercials have basically implied it. And here's the thing: it's actually wrong. Almost completely wrong. So let's actually go dig into where oil really comes from, because the true story is honestly way weirder and way older than a bunch of dead dinosaurs. Let's start with the myth itself, because it's worth understanding why it even exists. The idea probably comes from the fact that oil deposits often sit in rock layers that are roughly the same age as when dinosaurs were alive, somewhere between about 66 million and 252 million years ago. So people just kind of connected the dots. Old rocks, old dinosaurs, boom, dinosaur oil. It sounds logical on the surface. But here's the problem: geologists have actually traced oil deposits going back way further than that, some more than 500 million years old, long before any dinosaur ever existed. So if dinosaurs aren't the source, what actually is? The real answer is honestly kind of underwhelming at first. And then it gets really interesting. The overwhelming majority of oil comes from ancient marine microorganisms. We're talking about things like plankton and algae, tiny organisms that lived in oceans and lakes hundreds of millions of years ago. Not big scary creatures, microscopic life. Trillions and trillions of them, constantly dying and sinking to the ocean floor over unimaginable stretches of time. So picture this: ancient sea teeming with these microscopic organisms. Every single day, some of them die and their remains drift down and settle into the mud and sediment at the bottom. This happens for thousands, then millions of years, layer after layer building up on the seafloor. Over time, more and more sediment piles on top, burying these organic remains deeper and deeper into the Earth's crust. Here's where it gets good. As that organic material gets buried deeper, it experiences two things that completely transform it: heat and pressure. The deeper something gets buried, the hotter and more compressed the environment becomes. Geologists actually have a specific term for the depth range where this transformation happens best. They call it the oil window. Too shallow, and it's not hot enough to cook properly. Too deep, and it gets so hot it turns into natural gas instead. But right in that sweet spot, over the course of millions of years, that ancient organic material slowly cooks and transforms into a waxy solid substance called kerogen, and then eventually breaks down further into liquid hydrocarbons, oil. And when I say millions of years, I actually mean it. This isn't some quick process happening over a few thousand years like some people assume. We're talking about a depth of roughly 2 to 4 kilometers underground, sitting at temperatures somewhere between about 60 and 120 degrees Celsius, slowly cooking for anywhere from 1 to potentially 100 million years before it fully transforms into usable crude oil. Nature basically ran an unbelievably slow pressure cooker experiment, and we just happened to be the species lucky enough to show up afterward and dig it out of the ground. Ask yourself this: how do we actually know this is true, and not just a slightly better guess than the dinosaur one? This is where the science gets genuinely fascinating. In the 1930s, a German chemist named Alfred Trebs was studying oil samples, and he found something remarkable inside them: tiny molecules called porphyrins. Now, porphyrins are basically molecular fossils. They're incredibly similar in structure to chlorophyll, the exact molecule that plants and algae use for photosynthesis. Trebs realized these molecules could only have come from ancient biological material, from things that were once alive and photosynthesizing. This discovery is honestly considered the birth of an entire scientific field called organic geochemistry, and it gave scientists their first hard chemical proof that oil comes from ancient living organisms, not from squished dinosaur bodies. Since then, researchers have found all sorts of these molecular fossils, sometimes called biomarkers, inside oil samples all over the world. These biomarkers are basically leftover chemical fingerprints from ancient algae and plankton, and they let geochemists figure out incredibly specific details, like roughly what kind of ancient environment the oil formed in, whether it was a shallow sea or a deep lake, and roughly how old the source material actually is. It's kind of like ancient DNA evidence, except instead of identifying a person, it's identifying an entire prehistoric ecosystem. Now, I do want to mention something interesting here because not every scientist historically agreed on this explanation. There was a physicist named Thomas Gold who proposed something called the abiogenic theory. Basically, the idea that oil and gas might form deep inside the Earth through non biological chemical processes, completely unrelated to ancient life, and then slowly seep upward into the rock layers we drill into. It's a genuinely interesting idea, and it did get some serious scientific attention for a while. But the overwhelming majority of geological and chemical evidence, especially those biomarker molecules TRABes and later researchers found, strongly supports the biological origin story instead. Most petroleum geologists today consider the abiogenic theory a minority position, at best a small factor in a few unusual deep gas deposits, not the main explanation for the oil we actually pump out of the ground. So once this ancient biological material transforms into oil deep underground, it doesn't just sit there quietly forever. It's actually still lighter than the solid rock surrounding it. So over millions of years, it slowly migrates upward through tiny pores and cracks in the rock, kind of like water soaking upward through a paper towel, just incredibly slowly. Eventually, this migrating oil either escapes to the surface and evaporates away, or if it's lucky, it gets trapped underneath a layer of solid, non porous rock that acts like a lid, sealing it underground in a reservoir. That trapped pocket is exactly what oil companies are searching for when they drill. Here's a name worth knowing if you're at all curious about how humans actually learned to find these hidden reservoirs: Wallace Pratt. He's often called the father of American petroleum geology. Back in the early 1900s, the oil industry was still figuring out how to find these deposits. Honestly, a lot of early drilling was just guesswork, drilling wherever there happened to be a bit of oil leaking naturally to the surface. Pratt helped completely change that. He pushed the idea that oil should be searched for, using actual geological science, studying rock formations, sediment layers, and structural traps rather than just blind luck. His approach transformed oil exploration from something closer to gambling into an actual predictive science. And it's a huge part of why the oil industry could scale up the way it eventually did. Modern oil companies have taken that idea even further today. They use something called seismic surveys, basically sending sound waves down into the earth and carefully measuring how those waves bounce back to build a detailed map of underground rock layers without ever drilling a single hole. It lets geologists actually see the shape of a potential reservoir trap from the surface, sometimes kilometers underground, before spending millions of dollars committing to an actual well. It's a genuinely wild combination, ancient microscopic life meeting some of the most advanced sound wave imaging technology humans have ever built, just to locate it. And that brings us to probably the most dramatic turning point in this whole story: what happened once humans actually figured out how to reliably find and extract oil at scale. In the mid to late 1800s, oil went from being this obscure, occasionally useful substance, mostly used for lamp oil actually, to becoming the literal foundation of the modern industrial world. It actually kicked off in a pretty small, unglamorous way. In 1859, a guy named Edwin Drake drilled the first commercially successful oil well in Titusville, Pennsylvania, using a technique borrowed from salt well drilling. Before that, people were mostly just skimming small amounts of oil off the surface of streams and ponds, where it naturally seeped up, barely enough to bother with commercially. Drake's well changed everything almost overnight. Within just a few years, that quiet little town in Pennsylvania turned into a chaotic boom town. Land prices skyrocketed, and prospectors rushed in from all over the country, hoping to strike it rich. In a scene that honestly looked a lot like the gold rushes happening around the same era. just with oil derricks instead of pickaxes. A businessman named John D. Rockefeller built an oil refining and distribution company called Standard Oil. And within a few decades, it became so dominant it controlled the vast majority of oil refining in the entire United States. Rockefeller became one of the richest individuals in recorded history, and Standard Oil eventually grew so powerful that the United States government broke it apart in 1911 under antitrust law, splitting it into more than 30 separate companies, several of which you'd actually still recognize the names of today. So think about the scale of that shift. Ancient microscopic algae dying quietly in prehistoric oceans hundreds of millions of years ago, slowly cooking underground under heat and pressure, eventually became the exact substance that a handful of businessmen turned into the most powerful industry on the planet, an industry that quite literally reshaped economies, started wars, ended wars, and built entire nations practically overnight. Before oil, most artificial light at night actually came from whale oil, which is a whole other wild story on its own, whalers hunting across entire oceans just to keep household lamps burning. When kerosene refined from crude oil turned out to be cheaper and more abundant, it basically saved a huge number of whale populations from being hunted into oblivion purely as an accidental side effect of a business decision. Rockefeller wasn't out there trying to save whales, he was trying to build a monopoly. But that's honestly one of those strange historical footnotes where an industrial shift ended up quietly reshaping an entire ecosystem most people never even connect it to. And here's the thing that really gets me. It's not just about gasoline in your car. Modern petrochemical processing takes crude oil and breaks it down into an almost unbelievable range of everyday products. Plastics, synthetic fabrics like polyester and nylon, many medications, cosmetics, fertilizer used to grow food, even the ink that might be used to print something you're reading right now. Genuinely take a look around wherever you're sitting right now. There's an extremely high chance that something within arm's reach of you exists because of oil. So why does any of this actually matter to you? Because I think there's something genuinely humbling about the whole story. Every time you fill up your car, or use something made of plastic, or take a medication in a little synthetic capsule, you're using material that used to be microscopic life floating in an ancient ocean that existed before dinosaurs, before mammals, sometimes before complex life on land even existed at all. That gas isn't some random chemical humans invented in a lab. It's the compressed, transformed remains of an almost incomprehensibly ancient ecosystem, sitting quietly underground for hundreds of millions of years, just waiting to be found. It's honestly kind of wild to think about how much of modern civilization, your car, your phone case, the fabric on your couch, exists because of something that was once alive, floating in an ocean, unimaginably long before humans or dinosaurs, or really anything we'd recognize today, ever walked or swam anywhere on this planet. And there's something else worth sitting with here too. Oil is finite precisely because of how it's made. It's not like wind or sunlight, renewing itself every single day regardless of what we do. Every barrel that gets pumped out represents millions of years of ancient biological accumulation that simply can't be replaced on any timescale that matters to us as a species. We're essentially spending an inheritance built up over unimaginable stretches of deep time, all within the span of a couple of centuries. That doesn't necessarily mean panic, but it does mean the stuff sitting in your gas tank right now is a genuinely non-renewable slice of prehistoric history. And once a particular reservoir runs dry, that exact deposit is simply gone. So next time you're standing at a gas pump or you catch a whiff of that gasoline smell, I want you to actually picture it. Not squished dinosaurs, an ancient, sunlit sea. Trillions of microscopic organisms living, dying, and slowly sinking down into the dark for millions and millions of years, quietly transforming under unimaginable pressure into the exact substance that ended up powering practically everything around you today. I'm Chio. See you in the next video.